So now let us go deep into the subject of EDC with an introduction part. And in R19 regulation, let us show you what are the syllabuses that we need to study and what are the topics we need to study in EDC. Here, you can observe here, this is R19 regulation syllabus. This is our course description because we have changed from R18 to R19 because your seniors are with R18 regulation autonomous. Now you are in R19 regulation autonomous. The course overview of EDC will be like this. This course explores the fundamentals of electronics and knowledge on discrete range of semiconductor devices, its construction, characteristics, analysis, and design of various electronic devices. So what are all electronic devices that are present in EDC means starting from vacuum tube. Vacuum tube. So because of some disadvantage of vacuum tube, we have gone for a diode. So after the diode, and diode has many applications in our electronic devices, and because of some disadvantage of diode, we have gone for BJT, bipolar junction transistor. After BJT, then field effect transistor. After field effect transistor, we have gone for operational amplifier op amp, right? So these are all the devices. These are all the devices what we need to study in electronic devices circuits. So this course also makes the students expertise in analyzing the principle of operation of diodes, transistors, and their applications. Means what is application of diode, what is application of transistor, means it's a BJT or it might be FET or it might be MOSFET. So what are their applications? And all this we will be learning in this electronic devices circuits. And I am assuring you that definitely you will be doing some mini projects also if you learn these concepts and if you learn this subject which is called electronic devices and circuits. So after completion of this course, before that the course prerequisite of this subject is engineering physics, because you should learn about engineering physics, then only you need to learn about electronic devices and circuits. Otherwise it's very difficult to you to understand electronic devices and circuits. So most probably already you have learned this engineering physics in first year itself, so it will become very easy for you to learn electronic devices and circuits. So after completion of the course, the learner or the student will be able to explain the construction principles of working principles and applications of various electronic devices. That means what are various electronic devices? That's just now I told you. It may be diode, BJT, vacuum tube, or FET, MOSFET, operational amplifier. So these are all called as course outcomes. What is actually a course? A course is called as a subject. A subject technical name is called as a course. Here what course we are learning? Electronic devices and circuits. This is called as a course. So after completion of learning of this course, what the students will be able to do means they may be able to do regarding all these points. What is that point? First point is they can explain the construction, working principles, and applications of various electronic devices like BJT, diode, FET, MOSFET, operational amplifiers. And the second point is they can analyze the characteristics of diodes and transistors. So what is the characteristic of diode? Like x-axis, what we need to take, y-axis, what is its operation, and if you want to draw a graph, what we need to take in x-axis, what we need to take in y-axis. Likewise, we can able to analyze the characteristics of diodes and transistors. Right, that is the second course outcome what you people will be going to learn after completion of this course. The third point is design the DC bias circuitry of BJT and FET for various applications. Right, you need to design a BJT and FET. What are all the required components we need to connect to BJT and FET, so that the BJT and FET will operate in a very good manner, and so that we get a required output at output side, and they should be
Sir, you muted yourself, sir.
Sir.
Sir, we are not able to listen.
Sir, the voice is not audible.
It's not audible. Okay, okay. Sorry. I didn't mute it. Now is it audible? Hello?
Sir.
Yes, sir.
Yes, sir.
Students?
Yes, sir.
Now is it
Sir.
audible? Before that,
Yes,
it's
sir.
not audible. Huh?
Yes, sir. Audible, sir.
Before that,
Yes, sir.
No, sir,
is
it is
it
not
audible
audible.
or not?
No,
Audible, sir.
Now it is audible
No,
now.
sir.
Before 5 minutes, is it audible?
No, sir.
No,
no,
sir.
sir.
No, sir.
Okay.
No, sir.
No, right. I will start from first. No problem. Okay. So this is the electronic devices and circuits. What we are learning the subject, right? Before that, in the last day after, before we have learned basics of EDC and what is the difference between our branch ECE, CSC, EEE, civil and mechanical, right? So now let us go deep into the subject called EDC today. So these are the regulations what we have undergone with the R19 regulation, because R18 regulations we have gone with a different syllabus. Now we have changed the syllabus and we have gone for R19 for you people guys, in order to make sure that for easy understanding purpose and in order to do some mini projects and major projects in electronic devices and circuits, we have been
Sir,
designed the
excuse me,
syllabus
sir.
accordingly.
Sir, excuse me, sir. Sir, we are at course outcome, sir.
Course outcomes,
We,
right?
yes, sir. We are stuck at course outcome, second points.
Second point, right? Thank you. Right. The second point, the learner will be able to analyze the characteristics of diodes and transistors. Right. So you might be drawing different characteristics of diodes and transistors. Right. You might be drawing what is on x-axis and what is on y-axis for diodes and transistors. So therefore, you can able to learn this one after completion of this course, and you can able to design simple circuits of BJT and FET for various applications. Like just now I told you, in a theater we have a public addressing system, we have a mics in theaters, so therefore if you want to increase the sound of a speaker or a mic, then you can able to design a circuitry for BJT and FET, and you can able to construct a simple amplifier circuit using BJT and FET. So these are all the course outcomes. Course means what here? Subject name of the subject is called a course. What is the name of this subject here? Electronic devices and circuits. So after learning this course, you might be able to do all these 4 points, right? So here this is the syllabus what we have undergone, what we have changed for R19 regulation, you people guys. Unit 1, we need to study about diodes and what is its application characteristics and what is its applications in other devices. And special diodes we will be learning. The enhancements of a simple diode are called special diodes, which are called the GNR diode, tunnel diode, LED, light emitting diode, photodiode. These are all you will be seeing in real time applications, right? Special diodes. Anyhow, every student should be able to do one mini project on this special diodes: GNR diode, tunnel diode, LED, photodiode, and all this. There are so many diodes, but for you people, in order to make sure that you understand very clearly and to do for mini projects very easily, so we have been designed only 4 diodes into consideration in this character in this syllabus, right? And unit 2, which is called application of diodes. So the main application of diode is used in rectifiers. So you will be learning completely the half wave, full wave rectifier and bridge rectifiers, which are called applications of diodes in unit 2. And also filters also we will be learning here in this unit 2. In order to eliminate some unwanted components, we are using filters here. So what are those unwanted components? How they are present in this electronic devices? You will all be learning over there. Suppose if it is thundering in the atmosphere, you will get a sound, buzzing sound in your mobile phone. So we can eliminate that buzzing sound, which is sound created by industries, sound created by wind, sound created by man-made, man. So all these noises can be removed by using these filters. So there you can able to learn in deep into filters in unit 2. And in unit 3 we'll go for an enhancement of diode, which is called as transistor. The transistor is also called bipolar junction transistor. Because of to overcome some disadvantages present in diodes, we are going for transistors. Next, the brother of BJT is FET, field effect transistor. So if we learn about BJT, then we need to learn about field effect transistor also, which is an enhancement to BJT again. Again, the enhancement to FET is called MOSFET, metal oxide semiconductor field effect transistor. These are all called as devices, electronic devices, right? So after that, fourth unit, we'll be learning about biasing, how to fix an operating point, what is an operating point, and what is a load line, methods of biasing. It may be fixed bias, self bias, collector to base bias, which is the best biasing technique. All these biasing techniques we'll be learning in this biasing technique. What for biasing, what is thermal runaway, what is the condition for thermal stability. So it's a very important, and it is related to industry also. So we can able to learn this one very easily, which is related to industry, right? And the last unit we will be learning about amplifiers. Amplifiers section, because the most important application of transistors, it is acting like an amplifier. So therefore, how FET acts like an amplifier and how BJT acts like an amplifier in various configurations like CE, CB, and CC, common emitter, common base, and common collector. Both an exact and approximate analysis we'll be learning in amplifiers. So dear students, this is a complete course syllabus what we have designed for you guys. And if you come to books, the first book you need to follow is Millman and Hakias, Jacob Millman and Hakias. It is in a color called black color. You can able to find all these books in the market, also in our library, digital library also. It is contained by many books. You can buy this book, or you can take this book also. The book name is called Electronic Devices and Circuits, and the pad is black color. So that's what it is also called, black pad. The author is Millman and Hakias. They are both foreign authors. They have written the book in the year 1970s. From that till now, it is being vastly used by students, professors, and PhD students, and also research scholars. So I suppose you to use this book, Millman and Hakias Electronic Devices and Circuits, because it helps you a lot for even for competitive exams also. Even I have also written one textbook from for electronic devices and circuits by Dr. T. Tirupal, which is me itself. It is going under publication, so you can able to buy, even you can buy that textbook also, so that it's a very language is very easily understandable in that textbook. But here in that first textbook, the language is somewhat difficult to understand, because the terms present are very technical terms, and therefore you can able to find some bit difficulty to understand those technical terms. So even you can buy my textbook also. It will be going to released by next month, so that that textbook, it can be understood by yourself, because it's a user friendly, because I have written that textbook. It is user friendly with the cooperation of Bindu Sweta ma'am, who is our assistant professor in our department. So it will be very understandable for you. And even if you want to do any mini projects, you can go for reference book, first book, which is called Boylsted and Nashelski. And the second book is also Gupta, Electronic Devices. It's very easily understandable, that textbook also. You can go through this textbooks also, right? So these are all the textbooks what we have designed for electronic devices and circuits, right? So now let us go deep into the subject, which is called Unit 1. Unit 1. Before going to Unit 1, I want to tell you some basics. I want to tell you some basics.
Small break, sir. Excuse me.
Hello?
Small break, sir. I wanted to conduct a survey. I just
Yeah,
pasted in the chat box. Please check.
yeah, ma'am. Yeah, dear students, please use chat box and take a survey. Please, ma'am. All the students are informed to take a survey regarding a small question. Please insert that question, ma'am. Hello, Bindu, ma'am.
Yes, sir. I already pasted in the post. People are giving answers also.
No, options doesn't come. No error. Options should appear here. Where they need to click on poll everywhere. Hello,
In the post, sir.
post.
Yes, sir.
Where is that post, ma'am?
1 second, sir. In this second EC 2019 batch, general post.
No, you paste it here in chat box, because they are available in chat box now. They can take a poll there.
Yes, sir. Already 6 members responded.
Okay.
Only 6 members responded.
Yeah, dear students, please respond in Teams, no, second DCE 2000 bracket 2019 batch. Isn't it, ma'am?
Yes, sir. People are responding, sir.
Yeah, yeah. Please, students, please do respond for that poll. It's a very important for you, because by that poll you will be learning what is the subject, and you will be hearing my subject also, what topics we are telling, and what is that internal answers we will be getting over there. Please look over that and please do answer for that. Total 125 students are present. I want to get 125 options. How many, ma'am?
Yes, sir. Totally 31, sir.
Only 31.
Yes, sir. $43.
Come on, still. All the students has to participate. Come on, students. Be
52.
fast.
52.
125 is the strength who has attended today. So please, 125 students, I request you to take a poll. Anyhow, we'll be observing who has taken the poll also, and we'll be intimating you. Who has not taken the poll also will be intimating you. Please, who has not taken the poll, you can submit the poll.
65 responses, sir.
Still. Otherwise, if you do not take poll, you are sitting in idle position. It means that you are not listening to the class. Dear students, still anyone? Still you need to take the response.
Dear students, last 30 seconds more. $76 responses, sir.
Be fast, dear students. Question is, which branch of engineering device works at lower voltages? Is it a EEE, ECE, mechanical, or civil? I think if you come to first class, you might be answering this question. Be fast. Only 80 responses. Come on, dear students, come on. You need to answer it. You need to answer for that. Still anyone? Do not sit idle in position. Please be active. Come to the class. Learn the class regularly so that you will be getting good knowledge and your life will be settled in a better position. And you will be earning some lakhs of rupees if you are more active in the class. Still anyone?
Sir.
Good response. 87 responses. So maximum they have opted for ECE. Very good. Keep it up, students. Keep it up. Because as we know that, Madam, poll has been ended. Madam, time is out.
Sir, you can continue, sir.
Yeah, ma'am. Right. Very good response. Still, you need to take that into consideration, right? Now, let us go deep into the subject of electronic devices and circuits. So, before going deep into the subject of units, all the units, unit 1, 2, 3, 4, 5, then let us study the introduction part of electronic devices and circuits, which is called semiconductor physics. Dear students, is it visible to you, semiconductor physics?
Yes, sir.
Yes, sir. Yes, sir.
Right, good. So let us go with semiconductor physics, which is the starting point of EDC, and it is a heart of EDC. I can say that, because if you know what is semiconductor, then you can able to learn all the units very easily, which are present in electronic devices and circuits. So in that semiconductor physics, the first topic is called atomic structure. You might be learning already all these concepts in physics itself or in intermediate also. But let me revise all these concepts so that you might be remembering all the concepts in a very good manner. And what is this? All these concepts. The first topic is called atomic structure, where atom. What is an atom? Atom is a combination of nucleus and electrons revolving around that nucleus. So I can say that here, atom is a combination of nucleus and nucleus which is present at the center. This is called as nucleus, and the electrons revolving around the nucleus, these are called as electrons. So here combination of nucleus and electrons is called as an atom. Both the combinations is called as an atom. Now here, this nucleus, what is this nucleus? Nucleus is a combination of, nucleus is actually, it's a positively charged particle. You can see here a plus sign I am keeping there. Why I am keeping plus sign? Because it is positively charged particle. Why it is called positively charged particle means because it is a combination of protons plus neutrons. Protons plus neutrons. Protons plus neutrons is called as a nucleus. And protons are always positively charged particles. So positive charged particles, when they mix with neutrons, then they will get more positively charged particles. So therefore, nucleus is a positively charged particle. Then if I mix this one, negatively charged particles with the neutrons, what is the charge of nucleus now? It is negatively charged, right? So therefore here, because in order to follow this condition and atomic structure, so we are mixing protons with the neutrons, which will become a positively charged particle, and that positively charged particle is a nucleus. And this is the nucleus what we are learning here. This nucleus, it's a positively charged particle plus sign, and the electrons are revolving around the nucleus. This is the first electron which is revolving around the nucleus. I can say this this nucleus which is revolving in first orbit, this first line of a circle, it is called as first orbit. It is called as first orbit. Because first orbit, how many electrons will be revolving around the nucleus in first orbit means it is equal to 2 electrons are revolving around the nucleus in first orbit. And similarly, there is a second orbit which is farther away from a first orbit, which is lying over here. This is called as a second orbit. In this second orbit, how many electrons are revolving around the nucleus means approximately 8 electrons are revolving around the nucleus. 8 electrons are all are of negatively charged particles. So therefore, 8 electrons are revolving around the nucleus. So as you move further away from this nucleus, you have various orbits. Various orbits you have. So likewise, then if you draw a curve like this, you have the structure like this is what called as the nth orbit, or this is called as last orbit or nth orbit. Last orbit or nth orbit, or it is also called a valency cell, or because the electrons are present in valency orbit, or it is also called valency orbit, or it is also called valency cell, SHELL. Shell is also called as an orbit, right? Now see, as the electrons are moving further away from the nucleus, the electrons energy, what happens is electrons energy which is attracted by the nucleus decreases, because you can see here, if an electron is present here, what happens if an electron is present? It is rotating around the nucleus. How many electrons are there? 2 electrons. Likewise here, how many electrons? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are present. Likewise, how many electrons are present in last orbit? It is equal to 2n square. What is 2n square? N is number of orbit. Very, very important for competitive exams. 2n square. What is n? N is number of orbits. Number of orbits. Suppose first orbit. If it is first orbit, how many electrons are revolving around the nucleus? N is equal to 1. If it is n equal to 1, so what happens? 2 into 1 square. 2 into 1 square, how many? 2. If it is second orbit, what is n is equal to? 2. N is equal to 2 means how many? 2 into 2 square. How many? 8 electrons. If it is third orbit, how many electrons? N is equal to 3. So n is equal to 2 means 2 into 3 square. How many? 18 electrons. Likewise, can you tell me how many electrons are revolving around the nucleus in the 10th orbit? Anyone? Unmute your voice and tell me how many electrons are revolving around the nucleus in 10th orbit?
200.
200.
200.
Speak loudly. 2 into 10 square. How
200,
many?
sir.
200.
Very
200.
good. 200 electrons are
200.
revolving around the nucleus at the 10th orbit. So this is a very, very, very important formula for competitive exams like GATE exam. 2n square. Very, very, very important for competitive exams. 2n square. Right. Now see the structure. This complete thing is called as an atom. Combination of electrons and nucleus. Now here there are various important points we need to study here. Here only 2 electrons are revolving around the nucleus. How much energy is possessed by this second orbit? Energy means the energy possessed by first electron, energy possessed by second electron. So what is the total energy possessed by the first orbit means it is equal to first electron energy and second electron energy. Addition of first electron and addition of second electron energies. Now what is, suppose for example, one electron possesses 1 joule. If I consider second electron possesses 1 joule, how many joules of energy is first orbit possessed by? It is equal to how much? 2 joules of energy. 2 joules of energy. Another important point, energy of first orbit, approximately it is equal to 2 joules. This is for example, I am taking 2 joules. First orbit, how many? 2 joules. What is the second orbit energy? How many joules in second orbit? How many
8
joules in
joules.
second orbit? 8
8
joules.
joules.
8 joules. Likewise, what is the energy possessed in third orbit? How many electrons are revolving in third orbit?
16
18 joules.
Huh?
18 joules, sir.
18, not 16, 18. It is equal to 2 into n
18
square.
joules.
N is equal to third orbit means 3.
3.
3 square 9. 9 into 2 how much? 18. So 18
18.
electrons. How many joules? 18 joules. 18
18
joules
joules.
of energy. Now there is a competitive exam question here. As you go farther away from the nucleus, as you are going farther away from this nucleus like this, while you are going like this to last orbit, what happens to energy possessed by all these orbits? Is it increasing or decreasing?
Increasing, sir.
Increasing.
Increasing, very good. Suppose if I assume energy possessed by first orbit as E1, energy possessed by second orbit as E2, energy possessed by third orbit as E3, energy possessed by dash orbit is En, then tell me, what is the relation? What is the relation? Tell me what is the relation?
Descending order.
Descending order or ascending order? E1 is less
Descending
than
order.
E2 or E1 is greater than E2? E1 is
Greater
less
than
than E2. E2 is less than E3. E3 is less than En. So like
Greater
En
than
minus
E3.
1 is less than En. So En, which is the nth orbit energy, is very, very larger than that of all the orbits. Very, very, very important equation. Please do write all this complete notes, all of you. Please follow this notes, write running notes. So you keep a separate notes and write running notes. Anyhow, you don't worry. I will be giving complete notes for you, and also even I will be producing a textbook for you also, which is written by me. So don't worry for that, and you will be getting a very good marks also here. But you need to learn the subject thoroughly here, and you need to procure a good marks in competitive exams like GATE exam or any other Infosys exam or BEL or DRDO or whatever it may be. All government services exams is carried by 10 marks in this EDC subject. So please do remember, EDC is the heart of electronics and communication engineering students. So most probably every competitive exam is carried by 10 marks. 10 marks. So please do remember that. So at most you need to take your pen notes, write every important point what I am teaching over here, so that you will be thorough with the subject and you will be having a good knowledge in the subject. So energy possessed by E1 is less than E2, E2 is less than E3, E3, En minus 1 is less than En. So last orbit energy is very, very larger. Similarly, now come to here, the next point. Next point. What is the attraction force of first orbit electrons towards this nucleus? What is attraction force? Is it large or small? Because they are very near to the
Large.
nucleus. Large. Very good. Very good. Attraction force of these electrons is very, very large. What is the attraction force of electrons present in second orbit?
Less than
What
first
is
orbit.
the attraction force when you compare with first orbit? When you compare with first orbit, what is the attraction force of electrons in second orbit? Somewhat less. Somewhat less, because the distance has been increased from nucleus to second orbit, isn't it? So the attraction force is lesser in second orbit electrons. Now what about if you take third orbit here? Suppose third orbit is here. What about third orbit? Attraction force of electrons present in third orbit is lesser compared to that of second and first. Likewise, what is the attraction force of nth orbit? Somewhat very, very, very less. Kada? Very, very less. Now, third important point. If you consider attraction force of first orbit as AF1, attraction force of second orbit as AF2, attraction force of third orbit as AF3, attraction force of nth orbit as AFN. Now tell me the relation. Anyone? Unmute your voice and tell me what is the relation. Is it less than or greater than?
AF1 is greater than AF.
AF1 is
greater than
very good. AF1 is greater than
greater than
AF2.
AF2.
AF2 is greater than AF3. AF3 is greater than so on AFN.
AF2.
AFN minus 1 is greater than AFN. So very, very important point. Please note this point also, which is called attraction force. Which is called attraction force. So totally here we have discussed the three most important points. One is number of electrons revolving around the nucleus. How many number of electrons? It is equal to 2n square. How many number of electrons? First point is 2n square. How many? Second point is energy levels. This is second point, energy level. This is first point, 2n square. Third point is attraction force. Right. Now let us see. let us go in deep again. Let us go in deep again. Let us go in deep again. Right. Is it visible to you, all of you, dear students?
Yes, sir.
Yes, sir.
Visible, sir. Yes, sir.
Yeah. Now we have learned three important points. Now let us go with the third point again. Fourth point again. See, this is the nucleus. This is the nucleus. These are the electrons revolving around the nucleus, and this is the atom, protons plus neutrons plus electron. What is this one? What is this one? Protons plus neutrons is called nucleus. Nucleus plus electrons is called complete atom. Now, here the energy. See what I told. Energy possessed by the electron revolving in first orbit. Energy possessed by the electron revolving first orbit. How many electrons in first orbit? Two electrons. Two electrons are there. No. If you merge these two electrons, add these two energies of electrons, what do you get? Complete energy you get. Right? Isn't it? So merging of all this, see, merging of this energy is called band. Please write it, all of you. Band. What is a band? Band means a group. Band means a group. It is called as a band. Band means a group. Group of energies which are merged in first orbit. First orbit is called first energy band. It is called a first energy band. So first orbit, if you merge all the energies, then you get a first energy band. First energy band. If you merge all the energies of electrons possessed in first orbit, that is called first energy band. Suppose there is a second orbit here, second orbit here. So if you merge all the electrons present in second orbit, what energy band you get? Second energy band you get. Suppose third orbit is there. Third orbit, how many electrons? 18 electrons. Second orbit, how many electrons? 8 electrons. First orbit, 2 electrons. If you merge all the energies of 18 electrons revolving around the nucleus in third orbit, what energy band you get? Third energy band. So what is band actually? Band means group of energies. Group means what? A band. So it is called as band. So you are grouping what? Energies. So that's what it is called as what? Energy bands. Energy bands. So what is first energy band? First energy band means merging of all energies of electrons revolving around the nucleus in first orbit is called first energy band. Second energy band, merging of all the energies present in possessed by all the electrons revolving around the nucleus in second orbit. It is called second energy band. Next, likewise, third energy band. So likewise here in this atomic structure, we have a last orbit here. Last orbit here. So consider this one as last orbit, and an electron is revolving around the nucleus in last orbit. Now, third point, important point, we have learned attraction forces. So what is the attraction force of last electron revolving in last orbit? It is very, very less, isn't it? It is very, very less. So what happens? Suppose if I give small energy to this electron present in last orbit for this one, if I give small energy, just if I tap this electron at last orbit, what happens? It takes energy from sunlight, or it may be if I tap it, it takes energy from the tapping system, and then what happens is this electron comes outside into atmosphere. This electron comes outside into atmosphere, leaving here hole. Now this is a hole here. There is no electron here because it has come outside from this atomic structure. It has come outside means it is present in the atmosphere now. It is present in atmosphere now. This is the first position after giving certain energy to the nucleus, to the electron revolving around the nucleus in last orbit, isn't it? I told you already what is this last orbit. It is also called as valency orbit. Valency orbit or last orbit. What are the electrons? What is the energy possessed by last orbit? What it is called? What it is called? Suppose if you go like this is first, second, third, and this is last orbit or valency orbit, What is the energy possessed by valency orbit? It is called as what band? It is called as valency band. It is called as valency band. Now the electron has come here into atmosphere, leaving here what? Hole. Suppose now the electron is revolving in atmosphere. Again, what happens is this electron searches for a hole in the atmosphere. This electron searches for a hole in the atmosphere. Suppose if it finds a hole here, what happens again? This electron takes energy from the sunlight or with some other extension of energy. So therefore, it moves from this position to this position. So this is first position. Now this is second position. Now the electron is present in this hole, and now this will become what? Again hole. So this is a hole. This is a hole, and this is an electron. Which is see the position of electron. It is moving from first position. So this is from this position to first position to second position. Again this electron finds a hole in the atmosphere like this. Again what it does? Again it jumps from this point to this point, leaving here what? Hole. Again it is filled by what? Electron. Now see the electron position. It is moving from and shifting from first position to second position to third position. Likewise, it keep on going like this in the atmosphere. Suppose it finds a hole again here. What happens? Again, suppose electron is here. Again, it will shift from this point to this point, leaving here what? A hole, and it is filled with electron here. So this is the process. See what is the path of electron now? What is the path of electron? Electron is moving from left side to right side. It is moving from this point to this point, this point to this point, this point to this point, like this. If it is moving in a very fast manner, right? If it is moving in a very fast manner like microseconds and nanoseconds, what happens? A continuous electron flow is observed. That continuous electron flow is called what? Current. What is that current? That current is due to what? That current is due to what? Electrons. So therefore it is called as what current? Electron current. It is called as electron current. If it is moving in a very continuously manner, very fast manner, from left side to right side, filling all the holes which are present in the atmosphere in various atomic structures. So therefore that position from one point to another point, when an electron is moving within a very fast manner, then immediately current is generated. That current is called electron current, isn't it? Did you get all of you? Is there any doubt in this electron current? Is there any doubt in this electron current? Anyone? Is it getting all of you?
Yes, sir.
Please respond.
Yes, sir. Yes,
Is
sir.
it audible for you?
Yes, sir.
Yes.
Sir.
Now, can you tell me
Yes, sir.
what is the opposite to electron is moving? Opposite to electron. What is moving opposite to electron? See, electron shifting from left to right. Left to right. Now, what is moving from right to left? Anyone? Anyone? Unmute your voice and tell me. What is the thing that is moving from right to left? In this arrow mark, in this direction, from this point to this point, left to right, electron is moving, isn't it? Now what is moving from right
Holes.
to left? See, this is right side and I am coming like this, say, towards left side. I'm coming towards left side like this. So what is moving from right side to left side? Anyone?
Holes.
Very good, very good, very good, very good. A hole is moving from right side to left side, isn't it? If a hole is moving from right side to left side, again this holes also carries a current, because they are also moving continuously. If electron is moving continuously, hole is also moving continuously in a very fast manner. So again, if you merge all these holes, you will get what current? Hole current. You will get hole current. Now what is total current now? What is total current? Anyone tell me? What is total current? Anyone? Total current is equal to, unmute your voice and tell me what is total current is equal to. Dear students,
whole current
whole
plus
current,
electron
very good. Whole
plus
current plus,
electron current.
very good. Whole current plus electron current. This is the total current that we are observing in the atomic structure. Now this is the current what we are getting in our houses also. If a light is glowing or fan is rotating, what is happening means a current is generating over there. How the current is generating? Because electron is moving from one point to another point in a very fast manner, so therefore current is generated there. So that current is in passing through copper wires, so therefore we are glowing a light in our houses, and therefore fan is rotated, therefore generator is on, whatever it may be, television is on, refrigerator is on, everything else. That current which is present in our houses, industries, everything, that current is generated in this process only. This is the process of generation of current in atomic structure. This current here what we are observing in our houses, that current is called total current, which is a combination of whole current plus electron current, right? So this is the most important point what we need to learn, all of you. Please do take this complete notes over here. If any type of doubt if you have, please unmute your voice and ask me. Is it clear, all of you? Dear students,
Yes, sir.
Yes, sir.
how the
Yes,
current is
sir.
generated, did you observe? With what electrons current is generated? Is it first orbit electrons or second orbit electrons or valency orbit electrons?
Valence orbit
Valency
electron.
orbit,
Very good,
orbit
very good.
electron.
Valency orbit electrons only current is generated. It's not due to first orbit or second orbit or third orbit, right? Only an atomic structure, it should contain last orbit. Last orbit, suppose there are certain atoms, silicon atom is there. What is silicon atom? What is atomic number of silicon? What is atomic number of silicon? Anyone?
13. 13.
Emma?
14.
14.
14.
Very good. 14. Atomic number of silicon is 14. Now tell me how many electrons are present in the first orbit for silicon? How many electrons
Two
are present in
electrons.
first orbit? Huh? 2
2,
electrons.
8, 4.
2 electrons. How many electrons are in second orbit? 8 electrons. How many are in third orbit?
18.
4 electrons. Now which is the last valency orbit for the silicon? Is it first orbit or second orbit or third orbit?
Third orbit.
Third
Third
orbit.
orbit. Very good. Third orbit.
Third
But here
orbit.
third orbit is called as valency orbit. How many electrons are revolving around the nucleus? Only 4. These 4 electrons will tend for flow of electricity in silicon atom. Suppose any material is made up of with silicon atom, then if a current wants to flow in that silicon atom, then the electrons present in third orbit, those electrons only are responsible for flow of current in silicon atom. That is what the conclusion over here, right? You please write a note, all of you, note, keep a note and write it. The current generated in atomic structure, the current generated in atomic structure, the current generated in atomic structure, the current generated in atomic structure is due to is due to valency electrons is due to valency electrons is due to valency electrons present in valency orbit is due to valency electrons present in valency orbit. Okay. Right. So next topic, energy bands. Or time is 9:55. If you have any queries, please ask me. We'll go with energy bands in next class. Is there any doubt in this? If you have any doubt, please let me know that. Please unmute your voice and ask me if you have any doubts. Bindu ma'am. Hello.
Yes, sir.
Is there any other poll?
One more poll is also ready.
Yeah, you can post, ma'am. Time is
Yeah,
9:55.
already. Yes, sir. Already posted, sir. People are responded. Some people responded.
Which one? Second one also. Oh, very good. Dear students, take this poll. Second poll. Which branch of engineering device works at lower frequencies? Which branch of engineering device works at lower frequencies? Please take everyone. You should take the poll. Otherwise, you are said to be in ideal position. Everything will be getting all information here. Those who are in ideal, those who are existing, those who are listening to the class, everything will be observing here in Microsoft Teams. Please take this poll. Which branch of engineering works at lower frequencies? Read the question properly. Dear students, read the question properly. Which branch of engineering device works at lower frequencies? Which branch of engineering works at lower frequencies? Which branch of engineering works at lower frequencies? Only 60 responses. Come on here. Go ahead. How many are there? 125 are there, I think. See, many are not responding.
Last question for the today's class. Can we imagine today's world without electronics?
Yes. (130) students are present, but see, you are not responding. I want 130 responses. Come on, dear students, please involve in the poll. Try to answer for it. Meanwhile, if you have any doubts, please ping me, or you can unmute your voice and ask me. Any students, if you have any type of doubt, you can chat in the chat box also, or you unmute your voice and ask me. Hello, sir. Sir. Dear students, if you have any type of doubt, please ping me or ask me. Unmute your voice and ask me. See, 130 students are present. But how many are taking poll, ma'am? Only 80 responses. See, very bad, ma. Only 80 responses. What all the people are doing, I do not know. You are just making on the device and then you are leaving, I think. It's very bad. Yeah, the last poll. Can we imagine today's world without electronics? Good responses. But all of you has to respond. Only 80 responses. Come on here. You are easy, guys. Don't be lazy. Be fast. I will conclude the answers for today. The first poll, what we have taken. The first question is, which branch of engineering device works at lower voltages? Which branch of engineering works at lower voltages? It is ECE, because diode works at how much potential? 0.2 volts. Germanium 0.6 volts for silicon. Right. So lower voltages means ECE. Higher voltages means what? Triple E. Higher voltages means triple E. Right. Next, second question. What is the second question? Which branch of engineering has which branch of engineering device works at lower frequencies? What is a device that works at lower frequencies? It is triple E. Transformer. Take a transformer. Its frequency is 50 hertz only. But if you take ECE components, they are working at higher frequencies, isn't it? Even what is the frequency of AM radio? It is 555 kilohertz to 1650 kilohertz. What is the frequency range of FM? It is 88 megahertz to 108 megahertz. Mega means how much? 10 power 6. Kilo means how much? 10 power 3. And what is the frequency range of satellite? 6 gigahertz. 6 by 4 gigahertz means 6 gigahertz uplink frequency. Downlink frequency is 4 gigahertz. Giga means how much? 10 power 9. 10 power 9. So higher frequencies belongs to what branch? ECE branch. Lower frequencies belongs to what branch? Triple E branch. Right. The last question. Can we imagine today's world without electronics? Very difficult to imagine, isn't it? Because you are all working under electronic devices only now. So we cannot imagine today without electronics, because all our electronic components are making earth smaller, isn't it? They are making earth smaller. If you want to talk to a person living in USA or Australia, how much time it will take? Just 9 seconds you need to dial in your mobile phone. So therefore you will be talking to your friends and relatives. So it is making earth very smaller. Who are making earth smaller means ECE. That means electromagnetic wave will travel from one point to another point. It will rotate the earth and it will go. So therefore electromagnetic wave means what? It belongs to ECE. So ECE makes the earth very smaller, isn't it? Right. Even we have sent a satellite to Jupiter also. Jupiter, Mars and everything. So even we are getting a signal from Mars, Jupiter and also. So therefore say how many longer distances they have. Moon. MOM we have sent a Mars orbiter mission we have sent and missions, so many satellite missions we have sent to moon also. So therefore Chandrayaan 1 we have sent, Chandrayaan 2 we have sent. So therefore all are working with greater frequencies there. So we are making longer distances smaller means it is due to electronics branch. So feel proud that you are electronic student, right? So please go through all this what we have learned today, how the electron is flowing, how the current is flowing from one point to another point. So therefore we'll meet in next class. Okay, thank you all, thank you guys.
Thank you,
Thank you,
sir.
sir.
Thank Thank you. If you have any doubt,
Thank
please
you,
you
sir.
can ping me, or you can chat with me, or you can ask me. You can unmute your voice and you can ask. Right?
Okay, sir.
Thank you.
Thank you, sir. Okay, sir.
Thank you. Thank you. Thank you.
Yes, sir.
Bye, sir.
Thank you, sir.
Bye. Bye. Bindu ma'am. Thank you, ma'am.